In this video, we're going to talk about some other transformations: reflection over the x-axis, a vertical stretch, and vertical compression. So if we can see here, what's important here is now we have this negative that's in front of our function. So when we looked at the other ones, we had no negatives in the front. So our horizontal shift, it happened with whatever was happening with the x. For our vertical shift, it happened with the outside of the function. So now we're looking at what's being multiplied to the function. So again, we're dealing with the same kind of function, and we do not have an equation for that. So let's go ahead and put in our parent function coordinates, because we're always comparing everything to the parent. So that means that this was 0, 0, this is 1, 2, this is 4, 2, and this is 6, 3. And I could simply have gotten those coordinate values from looking at those points on my graph. So let's see what transformation I want to do. Notice now a is -1. I'm going to leave h as 0, and I'm going to leave k as 0. So let's clean this up. So here I have f. Well, x minus 0 is x. I have a -1 being multiplied to that function, and I'm adding nothing to it. So this is my new function. Where's my hk? Well, right here. My hk, which is my vertex or my center, is 0, 0. So let's talk about transformations that happen. So what's happening here? I'm multiplying -1 to the value of my y. So if I multiply -1 to 0, I get 0. If I multiply -1 to 2, I get -2. If I multiply -1 to 2, I get -2. And if I multiply -1 to 3, I get -3. So the values I'm now looking at for my coordinates, that's my x, and that's my new y. So let's go ahead and plot these values. So I still had 0, 0 right here. But now I have 1, -2. So you can see how that jumped over that x-axis. This was 2 away on the top, and now this is 2 away on the bottom. Then I have 4, -2. Same thing here. 2 away from my x-axis, 2 away from my x-axis. And then I have 6, -3, which is right here. So you can see it jumped over my x-axis. So if I were to actually take this graph and fold it along the x-axis, these points are going to lay right on top of these points. That's a reflection. So the transformation I would write here is a reflection over the x-axis. And sometimes we just write ROX. That's what that means, reflection over x-axis. That's the only thing that happened. Let's look at our next example. Our next example, let's look at what we have going on here. Our A is a 2, our H is 0, and our K is 0. So if we clean this up, what's inside the parentheses, x minus 0 is simply x, plus 0 doesn't add any value, and I have a 2 in the front. So this is 2 times my y, which is happening here. Let's go ahead and write down our parent. Our parent is 0, 0, 1, 2, 4, 2, 6, 3. So remember, what am I doing? I'm taking 2 and I'm multiplying it to my function. So 2 times 0 is 0. 2 times 2 is 4. 2 times 2 is 4. 2 times 3 is 6. So now my new values are right there. So let's go ahead and plot those. 0, 0, 1, 4. 1, 2, 3, I'm sorry, I'm going the wrong way. 1, 4. 1, 2, 3, 4. And I have 4, 4. So if I go 4, 4, 4, 4 is up here. And then I have 6, 6, 6, 6 is up here. So you can see that there was a bit of a stretch. It got closer to my vertical. So the last one that we have is a vertical compression that we're going to look at. So if a stretch is bringing it up closer to the y-axis, a compression is going to be pushing it down. So let's see what that's going to look like. So my A is 1/2, my H is 0, my K is 0. So that means this is F, x minus 0 is x, times 1/2, and plus nothing. What is my vertex? My HK is my vertex, or my center, which is 0, 0. Let's put in our parent values here. 0, 0, 1, 2, 4, 2, 6, 3. So now what are we doing? We're taking 1/2 times our function. So we're going to multiply this by 1/2. Well, 1/2 of 0 is 0. 1/2 of 2 is 1. 1/2 of 2 is 1. And 1/2 of 3 is 3/2. That's also 1.5. Help you visualize that a little bit better. So now I'm having my input, my x values, and my new y value right there. So 0, 0 right here. Then I have 1, 1. Notice how that went down a little bit. It's kind of like squishing out. The slope isn't quite as steep. Then I have 4, 1. And then I have 6 and 1.5. 6 and 1.5 is right about there. So you can see that that got squashed a little bit. That's a compression. So the slope isn't quite as steep. We can look at that as slope. And here the slope is steeper, because we can look at that like you would slope. So that's how you would do transformations of functions.